Hello students, I am Dr. Shilpa Kagoda, Associate Professor, Department of ECE, SJBIT. Today I am going to explain the concepts regarding to Module 2 in Basic Electronics, that is a bipolar junction transistor. So in this I am explaining today fixed bias, base bias circuit. This is the base bias in BJT. This is the circuit it has given. It is a base bias circuit and also known as fixed current bias. The base current remains constant at IB equals VCC minus VBR by RB. Here in this circuit diagram, the transistor bias arrangement is shown. It is also known as a base bias in BJT and also as a fixed current bias. The base current is a constant quantity determined by supply voltage BCC and base resistor RB. Because BCC and RB are constant quantities, IB remains fixed at a particular level. Unlike some other bias circuits, the base circuit in a base bias is a BJT circuit is not affected by the transistor current gain. So from this figure, the voltage drop across RB is VCC minus VBE and the base current is IB equals VCC minus VBE by RB. And the base emitter voltage VBE is taken as 0.7 volts for a silicon transistor and 0.3 volts for a germanium device. The transistor color current is calculated as IC equals HFE into IB. Next, applying KVL to collector region of the circuit. So here I have considered the same circuit, a base bias circuit, which is also known as fixed current bias. The base current remains constant at IB equals VCC minus VBE by RB. When we apply KVL to collector emitter region of the circuit, VCE is equal to VCC minus IC into RC to calculate the collector emitter voltage. Thus, when the supply voltage and component values are known, a base bias in BJT is easily analyzed to determine the circuit current and voltage levels. So this is the problem we have taken here. In this problem, the base bias circuit in the figure has given RB equals 470 kilo ohm, RC equals 2.2 kilo ohm and VCC equals 18 ohm. VB equals 0.7 volts and the transistor has HFE equals 100. So we have to determine IB, IC and VCE. So here first we will write down the given components here. What are the given data it has given here. In this here RB it has given 470 kilo ohm, RC equals 2.2 kilo ohm, VCC equals 18 volts, HFE equals 100. Then we have to calculate VBE, IB, IC and VCE. So to calculate IB here we know the equation VCC minus VB divided by RB. So here we know the VCC value, VBE value and RB. Substituting that we will get the IB here, which will be equals to 36.8 micro ohm. And next we have to calculate IC value. IC will be equals to HFE into IB. So substituting HFE value as well as IB value will be equals to 3.68 milliamps. Next we'll calculate VCE. VCE will be equals to VCC minus IC into RC. So substituting the values you will get that it will be 9.9 volts. So next, effect of HFE maximum and HFE minimum. So we know that when the transistor DC current gain is known, it is quite easy to determine the circuit bias conditions. However, in practice, the precise current gain of each transistor is normally not known. Therefore, the transistor is usually identified by its type number, and then the maximum and minimum values of current gain can be obtained from the manufacturer's data sheet. And also in circuit analysis, it is sometimes convenient to use a typical HFE value. HFE maximum and HFE minimum are always used for practical circuits. Base bias is rarely used because of uncertainty of the Q point. So this is next we have to consider the other problem here. So to calculate the maximum and minimum levels of IC and VCE for the base bias circuit, when HFE minimum will be equals to 50 and HFE maximum will be equals to 200. So first we will write down the given data here. Given RB equals 470 kilo ohm, RC equals 2.2 kilo ohm, VCC equals 18 ohm volts, HFE equals 100. Then we have to calculate VBE, IB, IC and VCE. So first we will calculate here IB, which will be equals to VCC minus VBE by RB. So substituting all the values, we will get IB equals 36.8 micro ohm. Next, in the problem it has given that for HFE minimum, it is given 50. So therefore IC will be equals to HFE minimum into IB. Substituting the values, which will be equals to 1.84 milliamps. Then VCE will be equals to VCC minus IC into RC will be equals to 13.95 also. Next we will calculate for the maximum value, that is for HFE maximum. For HFE maximum, same we will calculate IC as well as VCE here. IC equals a HFE maximum into IB, which will be equals to 7.36 milliamps, and VCE equals VCC minus IC into RC will be equals 1.8 volts. So next we will draw the load line and Q point for different HFE values. So base bias using a PNP transistor. So here all the base bias in BJT circuit is discussed so far. Therefore we will use the NPN transistor here. So figure shows the circuits that use a PNP transistor. In this figure we have to note that voltage polarities and current directions are reversed compared to NPN transistor base bias circuits, because it is normal to show the supply voltage with the positive terminal uppermost. The circuit is redrawn in this figure B. This is the way that the circuit would usually be written here. So it has given here the figure A. In the figure A, base bias circuit using an PNP transistor, and the second figure B is, it's a usual way to show a PNP transistor circuit with the positive terminal of the supply uppermost. Next we will find the equations here. IB equals VCC minus VB by RE, and IC will be equals to HFE into IB, where we can calculate HFE value for both maximum value as well as a minimum value, and VCE equals VCC minus IC into RC. Therefore the above equations can be applied to analyze the PNP transistor base bias in BJT circuit, exactly as for an NPN transistor circuit. This is some of the questions on this base bias circuit. So we have to write with a neat circuit diagram, explain the working of a base bias circuit. Second one is explaining the operation of a base bias or fixed biasing for transistor. Next, third one is for a PNP transistor using CE config, explain the working of base bias circuit. Next one is if the base bias circuit uses a transistor. So here this is a problem. Here we have given HFE maximum and minimum value. We have to determine the maximum and minimum level of IC and VCE. That means that while calculating IC and VCE value in this problem, we have to choose HFE value. First we have to choose minimum value, then we will choose maximum value. By using that we can find IC and VCE value. Next, fifth one is a base bias circuit has VCC equals 24 volts, RB equals 390 kilo ohm, RC equals 3.3 and VC equals 10 volts. So calculating the HFE value and determine the new VCE level when a new transistor is substituted with HFE equals 100. Thank you.